Hello, students. Did you miss me? It was nice to have a week off, and now we're back. Unit 8 in the home stretch. Let's talk about how much we love the planet. Here we go. Okay, so the biosphere. Bio means life. Sphere actually kind of means like circle, but the biosphere is the part of Earth where life exists. Basically, you guys, it's like seriously everywhere. The only places that don't have life would probably be like the really, really, really cold parts of Antarctica, the North Pole, South Pole. Now, if you were to collect everything that was alive on the Earth, it would be called the biota. So there's two new vocabulary words. Now, see where it says draw symbol next to each word. So you have an empty box next to each of these. What I was thinking I would want you to do is in the box, so for biosphere, maybe you could just draw like plant. This is just good for those of you that have, that's a leaf by the way, and a poodle for the animal. You don't really have to draw a poodle, but you know, plants and animals. That would be the biosphere, all of the Earth's life. Hydrosphere, when you hear hydro, I hope you automatically sort of know that that means water. Hydrosphere, I'm drawing a little water drop there. Hydrosphere is all of the Earth's water. So not only is it all the Earth's water, but it also includes the ice and the water vapor. So FYI, that is a lot of water. Next up is the geosphere. Geosphere, that would be like like the rocks. I'm going to draw a mountain. Yes, that is a mountain for a geosphere. Finally is atmosphere. So atmosphere is all of the air, the clouds, the smog, the goodness. That would be the atmosphere. Now, there's this thing called the Gaia hypothesis, and it says that, you know what, the Earth is kind of alive, but it is not a thinking being. So, meaning it's not like saying, hey, how about an earthquake on Friday night? No, it's not thinking, but it is dynamic. It's alive. It's changing constantly. We know it looks very different than it did in the past, and it's going to continue to change and look different. So in that way, it is somewhat alive. However, it does not think, and it does not regulate its system. Hey, guys, this is on the test. Climate. What's the difference between weather and climate? Now, climate is a long-term pattern. Long-term pattern. So, for example, in June, it is usually cloudy. I don't know if you ever noticed that. We're always so ready for summer, but it is usually cloudy in June. That is its climate. Weather would be, it is 72 degrees today. That would be the weather. So those are two words. Climate, long-term pattern, weather, the right now. All right, 3 climate zones, polar, temperate, and tropical. The tropical zone has a lot of biodiversity. That is where the rainforest is. The polar zone does not get very much sunlight. So if I was to draw the Earth right here, this here is the tropical zone. Tropical. This and this would be the polar zones. Polar. Man, it's hard to write. And then we have temperate and temperate. So those are the zones. The most curved regions have the most sunlight. There are 6 biomes, 6 main biomes on our planet. The first one is tropical. The weather there is it is warm all year. So you guys have a chart in your notes right now you should be filling in. Also, rains all year. This is where the rainforest would be. Most of the animals live in the trees, monkeys. So you guys may have to pause me on this part if you can't get everything done. So please feel free to pause and then resume, because I know there's a lot of writing here. I'm actually just going to show you the slide and move through because I think it's pretty self-explanatory. So this is the grassland, different weather patterns. Next up is temperate. There's two types of forest, the deciduous and the rainforest. I really love saying deciduous. I think that's so fun. So two types of forest. Rainforest is actually the kind that we would have like up in Big Bear with the pine trees and whatnot. That is actually the rainforest. Whereas the deciduous forest is where like the trees turn colors. This is not in California, unfortunately. Desert, brr, or woo, it's hot. It's either really hot or really cold in the desert. There's not really a lot of in between. It's also very, very dry. If you've ever been out to Vegas in the middle of the summer, so help you God, you know it gets to be like 120 degrees. That is the desert. Next one, taiga. So taiga, I think sounds like you're saying tiger, but it's not. So the taiga is, would probably be like, maybe like Montana, maybe like Alaska would be similar to the taiga. Next would be the tundra. Tundra, this is more parts of Alaska. It is cold there. The ground is permanently frozen. Yikes. So that's where these guys live. Alright, I'm going to send you a link to Mr. Parr. This is one of my favorites, you guys. I know you're going to love that song. We're doing this in class. So, that looks terrible. All of this pollution. Boo. Well, sorry to tell you, the United States, we are terrible because we use oil and coal as our main sources of energy. These are considered non-renewable resources. They actually take millions of years to form. In fact, it's actually dead dinosaurs that made the fossil fuels that we put in our car now. And obviously those take a long time to form, so that's why President Obama is always talking about making new, finding new sources of energy, because we just can't use however much we want. So, test alert. So, renewable versus non-renewable forms of energy. Renewable forms of energy, here you can see the sun, hydroelectric energy, geothermal energy, wind energy. Are all of these things, you know, the sun, hello, comes up every day. We know the wind, that we didn't have to charge for that. We're always going to get that. Maybe you've seen the windmills out by Palm Springs. Those are renewable sources. We're going to have access to more and more of them. Here's the kind that aren't. This is the oil we put in our car, coal, natural gas that turns your stove on, that probably heats your water as well. So none of those are renewable. Those all have a finite number. Now, your ecological footprint. Man, oh man, we really use a lot of resources in the United States. It would take 5 Earths, 5, to sustain the world population if everyone lived like we do. 5 Earths. And what we're talking about is the amount of land to produce food. First of all, if you eat a hamburger, that was once, sorry to tell you, a cow. At some point, that cow had to eat grass, and he had to take up some space. So it's including that kind of land. It's including the water the cow had to drink. It's including the time for the butcher to slaughter it. It's including the pig or the cow parts driving on a truck to the supermarket so that you could pick it up. All of those things. Like, it's crazy when you start to think about it, how our food really impacts the environment. Now, in class, we're going to calculate our own ecological footprints. It's really interesting because we can see, you know, how much are we really using. And Alright guys, remember when we watched the video about the human population? There are 6 billion people on the earth right now. And remember when it had the different jars and the water was dripping into them? Remember that video? Remember that? So there is however many people the earth can support, that is called carrying capacity. However many people the earth can support. Technology has increased carrying capacity. Test alert. Here's how it has. Farming. So agriculture and medicine has increased the carrying capacity. Those are 2 ways that it has increased. This was a pretty quick video, but we will definitely talk about stuff more. Don't worry about a thing. Now, here is your question. Oh man, here's your question. How many Earths does it take to support an American? That was just a few slides ago. How many Earths does it take? For an American. So this was video 1. See you in a little bit for video 2.